everyone! Welcome to my channel, Math is Fun channel. This is an educational channel to help you understand and love mathematics. Again, this is intended to those students and learners who are answering their modules out there and also who are doing their online classes. This channel will help you understand about mathematics. You want to improve your performance and also your skills in solving mathematical problems, then this channel will help you to do that. Okay, so always remember that in this video, this will encourage you to change your perspective about mathematics, that math is not a difficult subject, but it's easy, fun, and interesting. So math is exciting. Okay, so please do not forget to subscribe this video. Please send this one to your friends, especially those who are in need of this video discussion. And please watch first before you subscribe. Do not forget to subscribe my channel, click like, and also you can comment below in this video discussion. So are you ready? And I am also ready. I know you're ready, and I am also ready, rather. So let's start our discussion. So our discussion will be something to do with this. So you are all excited with our new topic for this in this video discussion. So our topic will be related to, as you can see, real numbers. Wow. So real numbers as opposed to fake numbers. Okay. So when we say real numbers, of course, real numbers are every number, all numbers that you can see. These are real numbers. Okay. Most or common numbers that we usually encounter in our day-to-day living. So therefore, any number that you can find on the number line, they are real numbers. So real numbers have two categories. So what does it mean? The number line goes on forever. Every point on the line is a real number. Take down note. We talk about number line, and please remember that a number line or every point on the line or in a number line is a real number. There are no gaps on the number line. Between the whole numbers and the fractions are, or there are numbers that are decimals, but they don't terminate and are not recurring decimals. So they go on forever. So these are examples of real numbers, as you can see there. So negative 8, 1.33, so on and so forth, square root of 101, and the fifth root of 225, and the rest of the numbers there. Okay, so there are examples of real numbers. So there are two kinds of real numbers, class. The first one are rational numbers, and the second one are irrational numbers. So rational numbers, to define it, a rational number is a real number that can be written as a fraction A over B. So again, rational number is a real number that can be written as a fraction form. A rational number written in decimal form is called terminating or repeating. Okay, again, a rational number written in decimal form is terminating or repeating. So please do not forget that one. So another, on the other side of it, examples of rational numbers, we have 16, 1 half, 3.56, negative 8, 1.333, so on and so forth, and negative 3 over 4. As long as the number can be written in the form of A over B or fractional form, then it is said to be a rational number. Take down note of that. Okay, so let's talk also about integers, since real number consists of integers. Integers are one of the subsets of rational numbers. Again, integers are, or integers is one, or integer is one of the subsets of rational numbers. So it's part of the rational number, the integers. So what are integers? Integers are the whole numbers and their opposites. Examples of integers are 6, negative 12, 0, 186, and negative 934. So now, Integers are rational numbers because they can be written as fraction with 1 as the denominator. So there are types of integers. We have natural numbers, or we represent it by a capital letter N. That means natural numbers are counting numbers from 1, 2, 3, 4, 5, so on and so forth. So in short, natural numbers will start on 1. It always starts in 1 rather. So the second type of integers, we have the whole numbers, okay, represented by a capital letter W. Whole numbers are natural numbers including 0. So they are 0, 1, 2, 3, 4, 5, so on and so forth. The only thing that differs here in the whole numbers from natural numbers did not or do not include 0. Okay, 0 is not included rather in natural numbers, but in whole numbers, 0 is included. Wow, so that's the difference. Are you learning so far? Yes, I know that. So we have the number systems, or the real number systems, the family of real numbers. If you have family, numbers also have families. We call it the real number system. So let's start with natural number and its part. Okay, natural number are counting numbers beginning with 1, 2, 3, so on and so forth. The next, we have the whole numbers. Okay, whole numbers, counting numbers beginning with 0, 1, 2, 3, so on and so forth. And of course, the next, the integers. We have integers are all the whole numbers and their opposites. So we have -3, -2, -1, 0, 1, 2, 3, so on and so forth. And of course, the rational fraction, sorry. The rational or the fraction. Rational, all numbers that can be written as ratio, sorry, as ratio of, as fraction. Okay, again, rational numbers, sorry, there's something in my mouth. Rational numbers are all numbers that can be written as a ratio or fraction. And of course, from the rational numbers, we have irrational numbers in a real number. So irrational numbers are a decimal that never ends and never repeats. So irrational numbers are decimal numbers that never ends and never repeats. Oh, so sorry. Oh, I'm so sorry for the inconvenience. Again, when we say irrational numbers, these are numbers that can never be expressed in the form of A over B. In short, you cannot write it as fractional form, A over B. Take no note of that. And of course, they're all part of, they are all parts of real numbers. We call it, or these are the real number system, the family of real numbers. So real numbers are all numbers that can be put on a number line. All numbers that you can find, yeah, you can find in the number line, these are all real numbers. Wow. So now let's talk about irrational numbers. As I have said, irrational number is a number that cannot be written as a fraction of the two integers. So in short, it cannot be written in the form of A over B. So it cannot be written in fractional form. Another meaning for irrational numbers, it is written as decimals that are non-terminating and non-repeating. Again, irrational numbers written as decimals are non-terminating and non-repeating. Take down note of that. So irrational numbers can be written only as decimals that do not terminate or repeat. They cannot be written as the quotient of two integers. If a whole number is not a perfect square, then its square root is an irrational number. So a repeating decimal may not appear to repeat on a calculator because calculators show a finite number of digits. You can try it in your house. Okay, so examples of irrational numbers, we have square roots of non-perfect squares. We have square root of 4 is not irrational because it equals to which is rational. So in short, you can still simplify or evaluate square root of 4 as 2. That's why square root of 4 is not irrational. So square root of 17 is an example because square root of 17 is not a perfect square. And of course, the pi. Are you familiar with pi? Pi is an irrational numbers. Wow, delicious. It reminds me about pie, pineapple pie in the Philippines. So delicious. Okay, let's try this. Let's try to identify if this is irrational or rational. Square root of 2 is irrational. Very good. B, square root of 20, square root of 12. Very good. It's irrational because it's not perfect square. What about square root of 25? Okay, very good. That's rational because rather it is a perfect square. 5 over 11 is a rational because it can be expressed as a over b. And square root of 66, that is irrational because square root of 66 cannot be expressed as fraction. In short, it's not a perfect square. So these are the things that we have to consider to identify irrational and irrational numbers. So let's have another example, classifying real numbers. Write all classifications that apply to each number. Okay, square root of 5. 5 is a whole number that is not a perfect square, correct? Therefore, it is irrational and real. What about letter B, negative 12.75? You try to answer with me. That is, negative 12.75 is a terminating decimal. When say terminating decimal, what does it mean? These are decimals that do not repeat. So that we call it terminating decimal. So negative 12.75 is a rational and real. What about square root of 16 over 2? It can be simplified as this. Square root of 16 is 4 divided by 2. That gives us 2. Therefore, it's a whole number, integer, rational, and real. So that's how you classify real numbers. Got it? I hope you got it. So now let's proceed to a fraction. A fraction with a denominator of 0 is undefined. Why? Because you cannot divide by 0. So it is not a number at all. So again, those who are trying to divide any number by 0, your answer will be undefined. It cannot be a number at all according to the definition. Okay? So do not forget that you cannot divide a number by 0, but you can divide 0 by any number. The answer is 0. Example, 0 divided by 1 is 0, but cannot be 1 divided by 0. So when your divisor is 0, your answer will be undefined. So now state if each number is rational, irrational, or not, or real. Square root of 21, it's irrational. And 0 over 3 is equal to 0 is rational. So now state if each number is rational, irrational, or not a real or not a real number. 4 divided by 0 is not a real number because you cannot divide, or 0 cannot be a divisor. So it's not a real number. So now, of course, that ends our topic about real numbers, the family of real number systems. So I want you to try to reflect this one, the exit ticket. If you have learned something in my videos, draw the real number system. I've drawn I showed you the illustration about this one, about the family of real number, or real numbers rather. So you can just rewatch the video if you just miss it, and explain the difference between a natural number and a whole number. We discussed this one also. So that's all for today. I hope you have learned a lot of things in my video discussion. So that's it. Thank you so much for listening. I hope everybody is doing good as of this moment and learning so far. If you learn something, please do not forget to share this one to your friends, and please do not forget to subscribe my channel and to continue rather. I'm so excited, that's why. Okay, continue to subscribe my channel and watch my video discussions for our next video. So thank you so much and have a good day. Always remember, math is